there is another numerical which is based on the alpha and the beta formulas, right? So the question is saying a segment of steel railroad track has a length of 30 meter when the temperature is 0 degrees Celsius. That means the initial temperature Ti is 0 degrees Celsius and the length is 30 meter, right? What is the length when the temperature is 40 degrees Celsius? That means now the final temperature Tf is 40 degrees Celsius and we need to calculate the final length Lf. Okay. So we will solve the first part first. So here the given is T equals to 0 degrees Celsius. Li is 30 meter. Look, is 30 meter which is given to you. And alpha for steel. So there will be a table. There will be a table which will be given to you in exams, which will be having all the values of alpha and beta. So you need to pick the value. So here I am just giving alpha for steel is 11 into 10 to the power minus 6. So if it is given aluminium, if it is given brass, if it is given copper, so all of the metals are having a different values of alpha. Okay, so you need to choose the value of alpha from the table and then you need to use it. Okay, now the formula use, this is the formula we already discussed in my video when I explained you. So we will just put all the values. So delta L equals to alpha. Alpha we know the value, this is the value. And then Li, initial length is 30 meters and the temperature, the final temperature, delta T. So delta T will be basically Tf minus Ti, right? So what is Tf? Tf is 40 degrees Celsius or Ti is 0 degrees Celsius, right? So Tf minus Ti is 40 degrees Celsius. So we will put the values. I'm just rubbing this. Okay. So we will just put the values and I'll get the answer 0.013 meter. Okay. Now, what is Lf? Lf, what is the length when the temperature is 40 degrees Celsius? So we have calculated delta L, right? So what will be Lf? Delta L will be Lf minus Li. What is delta L? Obviously Lf minus Li. So what will be Lf? Lf will be delta L plus Li, right? So this will be my Lf. So I'm just placing the values and I got the answer Lf equals to 30.013 meter. Okay. Now the B part. Suppose the ends of the rail are rigidly clamped at 0 degrees Celsius so that the expansion is prevented. That means there will be no expansion, right? What is the thermal stress set up in the rail when temperature is raised to 40 degrees centigrade? That means thermal stress is basically the pressure. Okay. So basically they are very rigidly clamped at 0 degrees Celsius and there is no expansion. So what is the pressure which is built up in the railroad? So tensile stress is basically the pressure and we all know what is the pressure. It is force per unit area. We all know this formula, right? So tensile stress equals to force per unit area, right? And always remember there is a formula Young modulus Y delta L over Li. So it is pressure or tensile stress which is also equal to Y delta L over Li and Y equals to Young's modulus. So and the value it is a universal value. This value will also be given to you. So 20 into 10 to the power 10 Newton per meter square. So this value will be given. Then 0.013 meter is delta L. We have already calculated here over Li. Putting all the values and getting the answer is 8.7 into 10 to the power 7 Newton per meter square. Okay. So you need to remember the formula of tensile stress and the relationship between this in the Young's modulus. Okay.